Okay, so you already watched the video on the process of long division and the process of synthetic division. Okay, any major questions before we move on? Okay, now we want to talk about some of the things that we can do with long division and synthetic division. Okay, so first of all, let's kind of talk about the process of dividing. You have a dividend, right, that you divide by the divisor. Okay, and so when that happens, you get a quotient. And what do you do if there's a remainder? You add the remainder over the divisor. Right? Okay. Now I'm going to give these some function names. We're doing this with polynomials, so I'm going to give these names like I would functions. Okay? So I'm going to call our dividend f of x, our divisor d of x, our quotient q of x, and our remainder r of x. Okay. There's something that we need to talk about called the division algorithm. Okay. Now, what you notice about this is I have, we have this division problem equals a quotient plus a fraction if there's a remainder, right? Is there a way to write this without any fractions? How would I get rid of all of the fractions in this sentence right here? Multiply by d of x. So if I multiply everything by d of x, we get something that looks like this. Okay? You don't need to write all of this down. Okay? This is what's important. Okay, this is the division algorithm. So basically, we are taking a polynomial and we're dividing it by a polynomial of lesser degree. Okay? I'm going to get a unique solution. All right? Instead of writing it as the dividend over the divisor, this is giving us a way to write the dividend a little bit differently. Okay? Now this is probably like the least important thing we do today, but I want you to know, okay, what it means. So we're going to do a division problem. Okay? And out of synthetic division and long division, which one do you think we need more work on?
Synthetic.
Really? Okay. Probably long division, right? Synthetic division, nice and quick, right? Long division, some of us probably would prefer synthetic. Okay. So let's look at a long division problem. Why do I say that this has to be a long division problem? Okay, our divisor is not linear. Our divisor is more than linear. Okay, so it has to be a long division problem. Okay? So our dividend, 2x cubed minus 8x squared plus 3x minus 9. Okay? This is something I wanted to talk about because what's true about the divisor? X squared plus 1. Okay? It's okay that it's like this, but typically we see an x term, right? And what did I tell you about missing terms? Put a 0. I would suggest doing that for your divisor as well. Okay, it'll help with the organization. All right, just for the dividing process, not for the end result. Okay, so here we go. X squared goes to 2x cubed how many times? 2x. Okay. Now we take our divisor times 2x. So x squared times 2x, 2x cubed. 0x times 2x. And 1 times 2x. And please remind me, what do we do with these two expressions? Subtract. Okay, so these should go away. That's the whole point. What are we left with? Negative 8x squared plus x minus 9, right? Okay. Now what? Okay, x squared goes into negative 8x squared how many times? Negative 8. So x squared times negative 8, 0x times negative 8, and 1 times negative 8. Remember, we're going to subtract. Change all the signs. And what are we left with now? X minus 1. Okay, so let's write down what we did. We took 2x cubed minus 8x squared plus 3x minus 9. We divided by x squared plus 1. And we got a quotient of 2x minus 8 plus a remainder of x minus 1. Right? So this is how we would write the answer. Right? You guys are with me here. Now, if we use the division algorithm, we could say, okay, we can write 2x cubed minus 8x squared plus 3x minus 9. If we multiply both sides by the divisor, we could say that this dividend is 2x minus 8 times x squared plus 1 plus x minus 1. Okay, this is that division algorithm that we talked about on the previous page, where you have the dividend is the quotient times the divisor plus the remainder. It's just a different way of writing your dividend. Okay. I believe you will have like 1 or 2 problems on your homework where they'll ask you to do the division and then rewrite it to here. Okay. What am I worried about for the quiz? I'm worried about the division part of it. Okay. Questions? Okay. Let's talk about a couple theorems. Okay. First of all is the remainder theorem. Okay. What does it mean when we get a remainder when we're dividing by a linear divisor? Okay. So first of all, we have a polynomial. We're dividing by x minus k. That is a linear divisor. And a linear divisor is nice for what kind of division? Synthetic. Okay? So if we get a remainder, this is saying that the remainder is that function value. Okay? So write it down, think about it, and we're going to go through an example of what that looks like. We're going to take 2x cubed minus 8x squared minus 3x minus 9, and we're going to divide it by x plus 1. So for our synthetic division, what numbers do I write in this first row? The -9. There aren't any missing terms, right? Okay. Since we are dividing by x plus 1, what number do I put right here? -1. Okay, if our divisor is x minus k, then this would be x minus -1. Okay, if you need a different way of remembering it, if you set the divisor equal to 0, that'll be the number you need to put out here. Okay, if that helps. All right, now for the fun, right? Oh. All right. So we bring down 2. What goes here? -2. Add them together to get -10. Multiply to get. Add to get 7. Multiply to get. Okay. And so then what goes here? -16, right? I always kind of like to make a little bar right here to kind of separate my quotient from the remainder. Okay, so our remainder is -16, right? What this is saying, the remainder theorem, that since our remainder is -16, if we put -1 into our function up here, if we evaluate our function at -1, it's -16. Okay, that's what that remainder theorem means. Now, is this more work or less work, or would it be the same as just plugging -1 into that function? What do you think? Okay, it might depend, right? If I say no calculator, right, then, depends how messy the multiplication gets here, or how messy it would be when you're plugging things in, right? If I tell you to evaluate it at 8, okay, taking 2 times 8 cubed, okay, that's gonna be kind of some large number, right? So some may argue it's efficient, some may argue it's not efficient, all right? What could be really, really helpful about all of this? Like, what would be a nice remainder that could tell us some things?
Could you check your answer to see if it's right?
What do you mean? Like, if you get a remainder of -16, then you can plug it in up here?
Yeah, to make sure it's -16, right?
Yeah. Yeah. But what would be a nice remainder here?
0.
0, right? And if we had a remainder of 0 here, what would that mean?
0.
Yeah. Okay, if whatever our remainder is, that's our function value, right? So if we have a remainder of 0, our function value is 0, which means we have a 0, right? Okay. Let's try this. Okay. I want the function value of 1/2 at x equals 1/2 of this. Now, first of all, okay, maybe you want to plug it in and just plug and shove, okay? That is a possibility. But let's go ahead and look at synthetic division, because we know that the remainder is going to be our value. So if we set up synthetic division, our function is 2x cubed minus 15x squared plus 27x minus 10. And I always kind of like to separate, like, here's where my remainder is going to be. All right, and what value goes out here? 1/2, because we're figuring out our function value at 1/2. Okay, all right, let's do this. We bring down 2 times 1/2, add it together to get -14 though, right? Okay, multiply by 1/2, and here we get -7, add to get 20, multiply 20 to 1/2 to get, and what's our remainder?
0.
Our remainder is 0. That's excellent. Okay. I will always make a happy face when our remainder is 0. Okay, so what does this mean? It means f of 1/2 is 0. Graphically, what does that look like? It goes, not the origin, it's going through the, if our function value is 0, it's happening on our graph. Wrong way. X-axis, right? If our function value is 0, we're on the x-axis, right? That's what it means to be a 0, okay? So if our remainder is 0, we have a 0, which is the same thing as an x-intercept, okay? Now, we've done a lot of work with polynomials the past couple days, okay? Well, I don't know how much you did over the weekend, hopefully a lot. But from our worksheets that we did a couple days ago, okay, if I gave you a 0, what did you know about the polynomial? If you have a 0, what do you know about a polynomial? On your blue worksheet, you did like 4 different problems. In your homework, you did a lot of problems where if you had a 0, you knew something about the polynomial. Okay, that's one thing. But what about like the algebraic polynomial? If we know a 0, then in the polynomial we know a what? A factor. Okay, if we have a 0, then we can write a factor. So let's talk about this. If we have a 0 at 1/2, then we can write a factor of what? X minus 1/2. Okay, here's our next theorem. If a polynomial has a factor x minus k, if our function value is 0, okay, like we just found. We just found a function value of 0, which means we knew a 0, which means we knew a factor. Okay. If we know a 0, we know a factor. If we know a factor, we know a 0. That is what that theorem is saying right there. Okay, so I have a question written up here asking you to verify that x plus 3 is a factor. How could we verify that we have a factor? Synthetic division. And what are we looking for with synthetic division if this is a factor? Our remainder is 0, right? Okay, so let's do that. We have 3x cubed plus 2x squared minus 19x plus 6. Since we're looking for x plus 3 as a factor, we're looking at a potential 0 of -3. All right. Okay, let's do this. Bring down the 3, multiply to get, add to get, multiply to get, add to get, multiply. It's a good day. Is x plus 3 a factor? Yes. It divides evenly into our function. Okay? There is no remainder when we divide by x plus 3. Okay? What did we also find out about our polynomial? Since x plus 3 is a factor, then what do we know about this? -3 is a 0. Okay? So let's talk about what we can do with this, okay? X plus 3 is a factor, okay? Which means we can now write our polynomial as x plus 3 times whatever is left over. 3x squared minus 7x plus 2. Okay? Now, can we write all the factors of this polynomial? Can we take this quadratic and factor it? Okay, let's do that. Well, we know to get 3x squared, we need an x and a 3x. Since this is a positive 2 and this middle term is negative, what does that mean about these signs right here? Both negative to multiply to get the positive 2. We can only get 2 by 1 times 2. Where should the 1 go? Where should the 2 go? I'm asking you. X minus 2 and 3x minus 1, so we can get negative x minus 6x. Great. So using the fact that x plus 3 was a factor, we have now factored our polynomial completely. That was nice because it was a cubic function that we were not going to be able to factor by grouping. So this was nice. Okay? All right, so this would be the complete factorization of our original function. Okay? You're going to be asked for that. When it says write the complete factorization, that means factor it down as much as you can. So here we go. We have 3 linear factors. Okay, I want to talk about the 3 things the remainder theorem can tell us. There are 3 things the remainder theorem can tell us. What are they?
0.
A factor, a 0, and it's a 0, what does that mean? It's an x-intercept, okay? So our factor theorem gives us, well, it gives us the remainder, right? Which, if it's a 0, it gives us a 0, okay? It's going to give us a factor if we have a remainder of 0, which is the same thing as a 0, okay? So these are 3 things that you've probably already written down. I just wanted to talk about them one more time, right? You've already written down the remainder theorem that whatever our remainder is, that's our function value, okay? If your remainder is 0, you have a factor, which also means we found a 0, an x-intercept on the graph. Okay. What you're going to use the most out of those 3 things written up there, verifying factors and finding zeros. Okay. I'm really not that worried about the function values unless that value is 0. Okay. That's going to be the most important thing out of everything. Okay. Verifying factors and finding zeros. Okay. Now I do want to go through one problem that you'll see in your homework. Okay. What's going to happen is you're going to be given a function. Okay. So here we have a fourth degree function. And it's going to ask you to verify that you have some factors. Okay. And after you verify the factors, write the complete factorization and then find the zeros. Okay. So first of all, if you're verifying factors, what do you need to do? Synthetic division, and we want these to divide evenly, so we're looking for a remainder of 0. Okay? So, let's do that. We have, what did I write 4? I should not write 4. 1x to the 4th minus 4x cubed minus 15x squared plus 58x minus 40. Right? Which factor would you like to look at first? X minus 5, so we're going to put a 5 out here. Okay, let's check it. Drop down the 1, multiply to get, add together, multiply, add together, multiply to get 8. Positive 8, multiply to get 40, so we have a remainder of 0. Right? Okay, so we have verified that x minus 5 is a factor. Now, we also need to verify that x plus 4 is a factor, but then we're also going to have to factor this out completely. So to verify that x plus 4 is a factor, do we have to go back to the original quartic function?
No.
What can we do? Okay, so right now we know that x minus 5 times x cubed plus x squared minus 10x plus 8 multiplies to get back to our original quartic function. So instead of dividing back into the original, we can divide x plus 4 out of this one right here. So we already have this synthetic division set up. You can just make a new synthetic division problem right here. Okay, save you some room on your paper. All right. So now we want to divide out x plus 4. So we're going to put a minus 4 right here, and we still want to look for a remainder of 0. All right. So drop down the 1, multiply to get negative 4. Add these for negative 3. Multiply to get 12. Add these two to get 2. Multiply to negative 8. And we get a remainder of 0. So we have verified that these two are both factors of our quartic polynomial. Okay? So let's write what we have so far. We know our original function is now x plus 5 times x, whoops, I wrote that backwards, I'm sorry, x minus 5, x plus 4, times, what's left over right here? What does this mean?
X squared minus 3x.
Okay. So if we want to factor this completely, we would write this as x minus 5 times x plus 4 times so here are all of the factors, which means our zeros would be what? 5, -4, 2, and 1. Can you guys kind of see how all of this is going to eventually fit together? Okay. Thursday and Friday, we talked about having zeros and what they're going to do to our graph, right? What's the ending and beginning behavior? What happens with the multiplicity as far as what's happening on the graph? Now, we're using division to help us find all these zeros, okay? So eventually, we're going to be able to put like everything all together from these past few seconds, okay? It's going to be really cool. All right. So here's your homework. Not a lot, okay? This is what is combining with section 2.1 and 2.2 as far as your quiz for Thursday. All right. We'll talk about it a little bit more tomorrow. And I'll give you some extra problems to do for review. That would be optional. But you will get a required problem set tomorrow. Okay? Please do not forget about those surveys, okay? That's kind of how I know how you're feeling about the homework, and I know that you're looking and doing the homework, okay? So please do not forget about that. I will have a survey up for 2.3 next hour, okay? So we have 5 minutes left of class. If you have not done any of your surveys, fill those out now so I know what's going on with your homework. If you're not doing it, just be honest and say the not available option. Okay, I can't rate myself because I didn't do it. All right. Otherwise, you can go ahead and get started on your homework. Okay. If there are any questions that you didn't ask me during homework time, now would be a good time to pull me aside and ask me. Okay.